Alright, moving on into lesson 15 here. Going to hit number 1 and number 2 more than likely. So Jada measured the height of a plant in a science experiment and finds that to the nearest quarter of an inch it is 4 3/4 inches. So if she's measuring this plant and she's rounding to the nearest quarter of an inch, and her measurement gets us 4 3/4, but she's kind of telling us her roundings thing here, so that means that she could have been off a quarter this way, or she could have been off a quarter this way. She rounded, so that kind of gives me a range of what her answer is. So I could add a quarter to that and get 5. I could take a quarter away from that and get 4 1/2. So I kind of know my parameters of her error, because 4 3/4 is considered to be her 100%. This question wants to know what's the largest actual height of the plant could be. That would be 5 if she's rounding that way. So that would be 5 inches. And the smallest amount that it could be 4 1/2. Alright, so that one's going to be 4 1/2, which is right here. And how large could the percent error be? Well, we need to find this by cross multiplying, dividing, and then subtract it from 100. So we need to find out what percent this turns out to be. So let's multiply that. 100 times 5, and then divide by 4 3/4. I'm going to type it in decimal form, so I don't have to type it in as a fraction. 105.3 is, I want to round that to the nearest tenth. So 105.3, which tells me that I've got about a 5.3% error from here to here. So this would be 5.3%. Okay, 5.3 to get from there to there. All right, so that's number 1. Number 2 is a little bit of a throwback to some old problems dealing with tables and equation writing. Water is running into the bathtub at a constant rate. That's kind of a, you get an idea, you're going to have a constant of proportionality. 2 minutes, so you know you got minutes involved. You get 2 minutes. The tub is filled with 2 1/2 gallons of water. So over here you got gallons. 2 minutes, 2 1/2 gallons. Use W for the amount of water, so we're going to call these W's, and we're going to use T for time in minutes. So these over here are T's. And we have to, let's see, in each case, what does the constant of proportionality tell you about the situation? Oh, hold on. It says write 2 equations. I'm sorry. Write 2 equations for this relationship. And then for each one, what does the constant tell you about the situation? Okay. So let's find the constant of proportionality first. Okay, so 2.5 divided by 2. Our constant is 1.25 to get us from here to here. So times 1.25. So that tells me that I can take T and multiply by 1.25, and that will equal the number on the W side. And to go the other way, I divide it the other direction. 2 divided by 2.5. To go the other direction, I would multiply by 0.8 to make it shrink to the other way. So times by 0.8 to go back this way. So I would take W and multiply by 0.8 to find out what T equals. Alright, so in both of these scenarios, like in the one where I got 0.8, in that particular one, to get that answer, I did T2 divided by 2.5, which was essentially taking the time, okay, minutes, and dividing by gallons. All right, so 0.8 represents how many minutes per gallon, and then the 1.25 was found by the reciprocal of that, gallons on top, minutes on the bottom, and that's how many gallons that we are running per minute. These are just unit rates. Okay, so 1.25 gallons per minute, or 0.8 minutes to run a gallon out of that faucet. A little bit of a throwback, but totally doable for us.